All right, one more quick video today on interfaces. I haven't really done a video on that. We just learned it before the break. So what an interface is, it's sort of a contract, and it allows us to create a lot of classes and a lot of objects that are going to have similar methods, but those methods might behave differently. So a good example here is, it's kind of a basic example, but let's do public interface animals. So what I'm going to do is I'm going to create an interface that basically says there's a lot of different animals out there, but my animal objects are all going to be able to do the same thing. So all of my animal objects are going to be able to, let's say, they're going to have an age. All animals have an age. Make noise. They all have some sort of noise that they make. And we can just live with that for now. So animals can do other things. Some animals maybe can fly or something like that. But for right now, all of my animals are going to have an age and a noise, like a sound that they make. And that's really what my interface is doing. It's basically saying, let's say I wanted to make an array of animals and then print out all the noises that those animals make. I don't have to create arrays of different types of animals. I don't have to worry about inheritance or anything like that. They can be completely different as long as they do those two things. So let's do a new class here, and let's do dogs. So dogs is going to be the first class that I do, and I'm going to implement the animal interface. So this keyword implements animals. There we go. Implements animals. This keyword, what that's doing is it's saying we're in a contract. And that contract is that I have to write these two methods. I can do anything else I want in this dog class, but I have to write those two methods. So first of all, now we said that it's going to make a noise. So we're probably going to need to store that as a field. And it's going to have an age. Okay. We need to construct a dog. So as soon as you do your class there, it's a good idea to make your constructor. Java will have a default constructor for you that'll kind of make it like an empty object, but it's a good idea to create your constructor ahead of time. For my dogs, I'll take a string name and an int age. And so this dot, noise. Noise, not name. This dot noise equals noise. This dot age equals age. Okay. So it still doesn't like me, and it doesn't like me because I haven't implemented the two methods. So Java, the compiler, isn't going to like me until I actually write these two methods. So I need to write a getAge method, and I need to write a makeNoise method. Turn this dot noise. Turn this dot age. There we go. I was doing a set method, not a get method. So now I have these two methods are written. My contract is fulfilled. I can do other things, but let's make this dog. Otherwise, there's no difference between a dog and other things. So woof. So I actually don't need noise as a parameter because we're just going to say all dogs say woof. And that's what makes dogs unique. So what this allows me to do, though, is I can And let's maybe say, just for fun, what makes dogs age different? Well, let's do this in people years or something. So this would return every dog year is 7 in people years or something like that. So that means dogs, it's going to calculate the age a little differently than we're people. So let's do a human class here. New class, humans, and humans, implements, animals. Again, that means I have a contract here. Private string noise, private age, int age. Again, I think it's a good policy to just make your constructor as you get going. Otherwise, you're stuck with a default constructor that you don't necessarily know or have a ton of control over. Let's make age the all we need to do. So this dot noise equals, people just say rabble rabble. That's what people say, rabble rabble rabble. This dot age equals age, so whatever parameter we give it. And again, the red X there is telling me Java does not like this. It knows I'm supposed to be implementing animals, and what that means is I have to write these two methods. I have to write a getAge, and I have to write a make noise. So until I write those methods, Java isn't going to like me. I mean, even if I keep the methods, well, I can't make them abstract, but I could just return nothing, or return like 0. But the getAge method, return this dot age. So now this is similar to the dog one, but notice how it's different. So this one just calculates the age is the same, but the dog one is going to calculate the age in like people years, so it multiplied by 7. So what this interface allowed me to do is to have two different objects that calculate age differently, but I could run just general methods on them, and I'll do that in just a minute here. Public string make noise. Let's return noise. Okay. So my noise is different for people. My age is calculated differently. But what the interface allows me to do is it allows me to make an array of animals. So animals test equals new dog, a 10-year-old dog. New humans. Let's say a 23-year-old human. So what I'm able to do now is I'm actually able to run and store animals into an array that are completely different classes. I don't actually need to write them the same way. They can have basically nothing in common other than the fact that they have to have a getAge and they have to have a make noise method. So I can then do, let's print test 0 dot make noise. So what this should do is it should make the noise of my dog object, and it does. Woof. If I change this to 1, then it should make rabble rabble. That's the noise of my human. So this is kind of a real basic example, but what an interface allows you to do is to basically have a single group of objects that behave completely differently, but they all have some common methods that are going to kind of produce something. So another good example that we're doing in class is a shape interface. Shapes all have areas and volumes and things of that nature. And so you can write a get volume method. Even though that volume is calculated completely differently, we could write some generic code here with shapes, and we can run an array of shapes and then calculate the volume of all those different objects without having to have all these different methods in my one class. I have all my different classes that create the objects, and each class knows how to implement the methods from my interface. So an interface is a lot different than a superclass, and they both allow you to create groups of objects that have some sort of commonality. But the big difference is that interfaces, you don't inherit anything. And so that means the objects can be completely different in the way that you actually calculate, or basically the way you write the code for that object. So it's a really good thing to use when you're trying to have a general category where you might have, let's say cell phones. If you're Verizon and you want to be able to have all of your different cell phones, and each cell phone has a method that you, let's say, predict sale or something like that, that predicts how many phones you're going to sell in the first month. So each phone might calculate that a little different based on the features and the brand. But what you could do is you could have the interface where the phones are completely different, and you calculate those predictions differently, but you could still group them into one array at some point, and then go through and run maybe a loop that would go through and calculate all of the different costs. So interfaces are pretty valuable tools. And what you want to do when you're creating hierarchies in this class is you want to just think ahead of time. Do you actually want to inherit features? Because if you do, you really want to be using a superclass. But if you don't want to inherit features and you just want to have a group that all kind of can run the same method, that's where an interface comes in.